Welcome back. Had a little mishap there on the camera. So back to number 3. We were talking about the fact that we have to find all of these things and then sketch, okay? So I'm going to just write down here in the middle all of these things I need to find. So I need to find where f of x is increasing. I need to find where f of x is decreasing. I need to find max and mins of f of x. And then I'm going to do the same thing with concavity. I need to find where f of x is concave up, where f of x is concave down, and then also the inflection points of f of x, okay? So that's what it's asking me to do up here. All right, so by given the derivative, this is the derivative, this is f prime of x, okay? All right, so where is your function increasing? Your function increases where the derivative is positive, above the x-axis. So it is above the x-axis from -5 to 2. And it is above the x-axis from 5 on. We're going to assume these keep going, okay, to infinity. So from 5 on also. Okay, your function is decreasing where the derivative is negative, below the x-axis. So that would be from -infinity to -5. And it's also below the x-axis between 2 and 5. All right, so looking at that, where are my max and mins? Remember that your max and mins are the roots of your derivative. So here are your possible max and mins, okay? So your max and mins are not the max and mins of that. The max and mins of this are the inflection points. The max and mins of your function are the roots of your derivative. All right, so if I change from increasing to decreasing, then that's a max. If I'm going from decreasing to increasing, that's a min, okay? So right here, what happened to the left? On the left, I was decreasing because this is negative. On the right, I was increasing, positive. So that means it looks like my function looks like this right there. So that means at x equals -5 is a min. Okay. All right. What about here at 2? To the left of 2, I was up here, which means increasing. So over here. And then to the right of 2, I'm down here, which means negative, decreasing. So that part of my graph is going to look like this, which means at 2, I have a max. And then over here at 5, on the left of 5, I am decreasing. And to the right of 5, I'm increasing. So it would be another min. So x equals 5 is also a min. So I have 2 mins, 1 max. Okay? All right, now, where is the function concave up? The function is concave up where the derivative is increasing. All right, well, my derivative is increasing till I get to right here. Let's call that 1, 2, let's call that -2.5, just so we all have the same numbers. And then it decreases till I get to right here. All that we'll call 3.5. And then we start increasing again, okay? So we are concave up where this thing's increasing. All right, so it's increasing. I'm gonna try to write this so you can see it. All right, so we're concave up. I'll write it over here. Okay, where I'm increasing. So that'd be from -infinity to -2.5. And then I'm also increasing here, so 3.5 to infinity. Okay? So where I'm decreasing on the derivative is where my function's concave down. So that would be from negative 2.5 to 3.5. That's where my function is concave down. All right, so remember, where are your inflection points? Okay, well, your inflection points are the max and mins of your derivative. So here's an inflection point at negative 2.5 because I went from concave up to concave down. And then this is also an inflection point because I went from concave down to concave up. Okay, so I have two inflection points at x equals negative 2.5 and 3.5. Okay, sorry for the scrunching in that, but it's hard. I was going to put all the answers down here, but then I got to keep sliding up and down, which is not fun either. So I apologize for the scrunching all those numbers into you. Okay, so now we have to graph. Okay, and they want you to make the sketch on its own graph. You could do it up here if that makes more sense to you. Okay, so let me show you how to sketch it on a different graph. So what I always tell students to do, this is the easiest way. Now you could sketch the graph from this. You don't even need this anymore. If this is correct, you can sketch the graph from what you have here. Okay, but sometimes they don't ask you for this. They just want you to go from here to sketch the function. So here's the easiest way I can tell you to do that. You're going to put boundaries. So I use dotted lines. They're not going to be asymptotes. I'm just dotted lines everywhere there's a root or a max or min. Okay, and I'm going to put those here. So I have a root at negative 5. So at negative 5 on my sketch, I'm going to put a dotted line. And so again, these are not asymptotes. I'm just putting some boundaries so I can see what I'm doing. And I have a max at negative 2.5. So at negative 2.5, I'm going to put another boundary. So honestly, you know, if you did this in pencil, it would be better because you could erase it when you're done, but it's okay if you don't. All right, the next boundary would be this root, which is at 2. Okay. The next boundary is a min at 3.5. So again, these are just helping me do my sketch. They're not part of the graph, okay? And then the last one would be over here at 5. So again, when you're doing a sketch of a derivative to the function, you're going to have boundaries. Something's going to change at every root and every max and min. That's where something will change on your graph. All right, so here's what I do now. I will use my up arrows like I told you before. Up arrows and down arrows for increasing and decreasing, and then the upside down U's and U's for concavity. So let's look to the left. So I have 1, 2, 3, 4, 5, 6 sections of this graph. So I want to know what's happening to the left of negative 5. I want to know what's happening in here between negative 5 and negative 2.5. I want to know what's happening between negative 2.5 and 2. Okay. I want to know what's happening right in here and over here. Okay. So we're going to start with increasing and decreasing. So to the left of negative 5, I am below the x-axis, which means I am decreasing. So I'm going to put a down arrow there for decreasing. All the way till I get to 2, I am increasing, right? I'm above the x-axis. So in this interval from negative 5 to negative 2.5, I am increasing above the x-axis. Between negative 2.5 and 2, I am still above the x-axis. So in here, I am increasing. And then when I get to 2, I'm below the x-axis. Until I get to 5, I'm going to be decreasing. So that means I'm decreasing in this little interval between 2 and 3.5, and also between 3.5 and 5, right? Because that whole area there, I'm decreasing. And then once I get to the right of 5, I'm above the x-axis again, which means increasing. All right, so looking at the derivative, then I can get my directions going. Now I'm going to do the same thing with concavity, okay? Wherever this derivative is increasing, I am concave up. So I'm concave up on the left side of negative 5 and also between negative 5 and negative 2. So I am concave up in these two areas. Okay, now when I get to negative 2.5, I am decreasing. And wherever I'm decreasing, I am concave down. So I'm going to be concave down till I get to 3.5. That's where I'm decreasing. So that means this area is concave down and this area is concave down. Okay, that's the 3.5 line. So what happens at 3.5? I start increasing again. And as soon as I'm increasing, the rest of the way, I'm concave up. Okay? All right, so that's all I need to draw this graph. Now remember, I don't know how high up and down I'm going to go. I just need to sketch this graph. So I'm just going to start somewhere and I'm going to be decreasing but concave up. Start anywhere you want to. Okay, so decreasing, concave up looks like that. Okay, now from here to the next line, I have to increase but stay concave up. So it'll be like that. Between this dotted line and this dotted line, increasing, concave down. So increasing, concave down, look like that. Between these two little dotted lines, I have to decrease and concave down, which would go like that. Then I'm going to stay decreasing, but I got to switch to concave up now. So decreasing, concave up. And then lastly, increase, concave up. Okay, so there's what a function would look like, f of x, based on the derivative. Now, look and see if that makes sense. Okay, remember I said you didn't need this to do that. You could have just used this. So is my graph increasing from negative 5 to 2? Here's negative 5 all the way to 2. Yes, it's increasing. And from 5 to infinity. Yep, that's where my function is increasing. Is my function decreasing from negative infinity to negative 5? Yes. And from 2 to 5? Yes. So that's true. Do I have a minimum at negative 5 and 5? Yes. Yes. Do I have a max at 2? As bad as my curve is, yeah, we'll call that the max. Okay, so I'm a little bit off on my sketch, but yes, there's a max. Am I concave up between negative infinity and negative 2.5? That's right here. Yes, I am. Here's an inflection point. And then I go concave down between here and here. There's another inflection point. And then I'm concave up again between 3.5 and infinity. So look at my inflection points, negative 2.5 and 3.5. That is correct. Okay. So all of this matches, and again, you guys can do the sketch from there. That's perfectly fine, but you do need to know how to go from a graph to the other graph because, sometimes you don't need all that other information. You don't need to write all this down if you don't need to, okay? Because you can easily go from the two graphs from one to the other. All right, let's do the last one then, part B. Okay, so again, where's the function increasing, decreasing? Where's the max and mins? Where's concave up, concave down? And where are the points of inflection? Okay. All right. Before I do that, okay, let's do this on this one. Let's go ahead and sketch the graph before I do all the information. Okay. All right, so remember what I said when you sketch the graph. You want your boundary lines at any max or min or any root. So we're going to put a boundary at negative 4. Remember, so I can do this without getting that information. So that's what I'm doing now. I'm going to show you how to do the sketch without it. All right, where's my next boundary? I would have a max at 2. Now, that's an inflection point there, so that's not part of my boundaries. Boundaries are just max and mins and roots, okay? And then I'm going to have another boundary, I don't know, let's call that 3.75, just so we all have the same numbers. So let's say that's the point, 3.75, okay? It's not really 3.5, so we'll go 3.75. And it's fine if you do 3.5. One of the things, on the free response of the final, that's real important that you guys label because sometimes the sketches aren't going through perfectly whole numbers. so there's my boundaries. All right, so I'm going to do my up arrows and down arrows. So on the left of -5, I am below the x-axis, which means my function is decreasing. Between -4 and 2, I'm above the x-axis, which means I'm increasing. Okay. Between 2 and 3.75, I'm still above the x-axis, so I'm still increasing. And then after 3.75, I'm down here, so that's decreasing. Okay. All right, now, concave up, concave down. Wherever the derivative is increasing, I'm concave up. So this is all increasing, all of that, okay? So that is all concave up. So until I get to 2, I'm concave up. So that's here and here. Once I get to 2, I'm decreasing. So after 2, concave down. Okay? All right, so we can make a sketch based on that. So again, doesn't matter where you start. Doesn't matter where you start at all. Just decrease, concave up. So that would be decrease, concave up would look like that. Then we're going to increase concave up till I get to here. So increase concave up till I get to here. Then increase concave down. And then decrease concave down. Okay, so there's a sketch of a function whose derivative would look like this. Okay. All right, so now again, you could get your increasing, decreasing from here, or you can get it from here. Doesn't really matter. So let's look at both. Where is your function increasing? Your function is increasing. Let's look at the function. I can easily tell it's increasing from -4 to 3.75. That's where the function is increasing. How do I know where it's increasing here? Where it's above the x-axis. So -4 to, so same thing. Okay, -4 to 3.75. Either way you look at it. Where's your function decreasing? If you're looking at the derivative, where it's below the x-axis, so that would be here and here. If you're looking at your function, it would be where it's decreasing. So here and here. So same thing. So -infinity till we get to -4, and then 3.75 to infinity. Okay. Either way you want to look at it. Okay, f of x has a max. Okay, where do we have a max? Remember, the max are the roots if it changes. So on this side, we went from decreasing to increasing. Decreasing to increasing is a minimum. All right, look, minimum. Here, we went from increasing to decreasing. If you go from increasing to decreasing, that's a max. So we have a max at x equals 3.75, and we have a min at x equals -4. Okay, so the roots are your max and mins. As long as you test, you gotta have something changing there. All right, then we're going to do concavity. So where is f of x concave up? Okay, f of x is concave up where the function is, where the derivative is increasing. So all of this is concave up. Okay, is that true? All of that is concave up till we get to right there. There's a point of inflection. All of this is concave up. All of this is concave down. So from -infinity to 2, concave up. Okay, -infinity to 2 is where this thing was increasing. Where it's decreasing is where it's concave down. So that would be from 2 to positive infinity. Okay, concave down. And here's your inflection point. Your inflection point is the max and mins of a function, of the derivative. So they have a max of the derivative at x equals 2. So we have an inflection point at x equals 2. Okay. Now, remember, I don't know any of the y values. Notice all of these are x's. All my intervals are x's all the time. So I have no idea what the height or how tall a graph is, okay? That's the one thing the derivative can't tell us. But it can tell us a lot about intervals, and intervals are always the x's, and that's really what I'm concerned about when I'm doing these graphs, okay? All right. Now, there's an extra worksheet and then the appendix pages, so if you guys want to work on the extra 2 problems on that extra worksheet, see if you can do those before we meet, and if not, I mean, we will go over them in class. Okay, so start working on those, work on your homework, and let me know if you have any questions.